Hi, in this video session I will talk about graphing a piecewise function. In many real-life problems, functions are represented by a combination of equations, each equation corresponding to a different part of the domain of the function. In this example, I have a piecewise function. As stated from name, it comes with the multiple pieces. In this example, I have f of x equals x plus 1 with the restrictions x equals greater than -5, x less than 0. And the second piece is fx equals x squared with the restriction of x equals less than 0, greater than 0, and x equals less than 3. Now, based on the graph of this function, we need to start graphing piece by piece. So I will start graphing the first piece with the restriction that's given. F of x equals x plus 1. Okay, x plus 1. Now I will start graphing, plugging in the two endpoints. The first endpoint, the lowest one, x equals -5. So f of -5 equals -5 plus 1. This end up with -4. So when x is equal to -5, y equals -4. So that's it. I get the first point, so I can plug the point on the x and y coordinates, and then I will start with the next one. So while x is equal to -5, y is equal to -4, -5 and -4, so approximately is this part. And as you see, I put it as a solid dot because -5 is equal, x is equal to -5, that means -5 is included in our solution set, is included in the domain. I will start with another endpoint. Another endpoint, the inequality says x less than 0. So 0 is not included in the solution set, but again, I will plug it just for the purpose of having a point. But in this case, I will plug it as an open dot, empty dot here, indicate this open circle indicates that endpoint is not included in the domain. So now that I have 2 points and I can graph this function, it's basically a straight line function. As you can see, m, the slope is equal to 1 plus the y-intercept. So I got a line that slants upward based on the slope that's positive. But I will plug another point just to make sure that my graph is moving through that point. So I will start with x greater than -5. I will start with x -1. So f of -1 equals, I will plug in the same, we're still using the first equation, -1 plus 1 is equal to 0. So that means while x is equal to 1, I get 0. So this point, basically, it's x-intercept. That's my x-intercept, this point. So while x is equal to -1, y is equal to 0. So that's another point on the graph. So if I want to connect these two points here, going through the -1 and 0, so that's my first graph. So this graph basically represents y equals x plus 1. So that's my graph. Now I'm going to start while x is equal, fx equal, let me start with this section. So I will start with fx equals x squared with the restriction x is greater or equal to 0, x equals less than 3. So I will start plugging in 0, that's included. The two endpoints are included, so I will start with the first endpoint 0. F of 0 here equals 0 to the power 2, which is 0. Then when x is equal to 0, y is equal to 0. That's another x-intercept, and also it is y-intercept at the same time. While x is equal to 0, y is equal to 0. So the two intercept here. So I got 1 point here for the second part of the equation. Okay, now I can plug 3 is included in the solution set. Okay. F of 3 equals 3 to the power 2, which equals 9. So here I have when x is equal 3, y is equal 9. That's another point on the graph, on the second part of the equation, on the function. So while x is equal 1, 2, 3, y is equal, let's say here, it's 9. So I'm going to plug this point here. So I got 2 points now. I can graph this part. But when I look at the graph, f x equal x to the power 2, it's basically a parabola. So here the parabola, I can graph it by just showing the basic parabola, which look like this. But in this time, I have restrictions. X is equal 0 and greater than 0. So basically, x is not equal negative, so this part of the parabola will be omitted. So only this part. So I'm going to grab this part. So let's plug another point between 0 and 3. I will pick 1. While x is equal 1, f of 1, y is equal 1. So I end another point 1 and 1 on the graph. So while x is equal 1, y is equal 1, that's the point here. So I'm going to graph this function using a red color. So it will be basically is a parabola here. This one stop till 9. So that's part of the parabola, which not this part is omitted, only that part. Now I can tell this function, which is this one here, this function is y equals x to the power 2. So that's it. This function is this graph. Now, once I'm done with the graph, the next step is to find the domain and the range of this function. Now, the domain of the function is basically is already given by the restrictions. So the lowest value for x is -5, and the highest value is 3. So my domain will be -5 and 3, but both of them are, the endpoint are included in the solution set. So my solution set between x between -5 and 3. -5 is included and 3 is included. Now, based on the graph, usually we determine the range of the function. Now, to scan the range of the function, I will move my pen. That's an easy way. I will move my pen from the negative part of the y and going up. So I will start with the -5. My pen is not touching the graph yet until -4. It says -4. My pen starts touching the graph. So -4 basically is the beginning of my graph. So that's -4. -4 is included again as a solid dot. And I will move my pen. So my pen is still touching the graph. Still touching the graph until 0, still touching the graph. Still touching the other part of the graph until 9, it will stop. Then 9 is the end point of my range, and my range at this side is -4 is included and 9 is included. So hopefully this will help you just to understand graphing a piecewise function. Thank you.